excited to introduce Jeff Smith. Jeff's from Grubhub, and he's going to be talking about the Puppet development workflow there. So you should have some interesting contrasts between the different workflows you've seen sort of in different places here. So thank you so much, Jeff.
No problem. Can everybody hear me okay?
Yeah.
All right, sweet. Quick show of hands, how many of us would identify ourselves more as a system administrator? Okay, how many developers? Okay, and how many of us are writing code of any shape or form regularly, like, more than 5 hours a week? Okay, awesome. Good, cool. So we're going to walk you through Grubhub's Puppet development workflow. The timing is going to work out great because we're going to be able to compare and contrast with some of the stuff that Bill and Chad talked about, some of the things that they're doing that are right that we screwed up, and some of the things that we might be doing a little differently. Quick intro about myself. My name is Jeff Smith. I'm the manager of site reliability engineering at Grubhub. Been a Puppet user for about 2 years now, and we absolutely love the product. We use it to manage all of our infrastructure, or at least all of our diner-facing infrastructure. We're still kind of making our way into the internal tool space. Yes, we are also hiring. I am the hiring manager, so we're looking for engineers, we're looking for systems folks. So if you're looking to make a change, let me know. Yes, there's free food, a lot of it. That's how I got my figure. So, if you're looking to put on a free 15, let me know. And my contact info is up there, jsmith@grubhub.com, dark and nerdy on Twitter, and all things dark in my blog where I post very, very infrequently. So what we're going to talk about today is we're going to give you a quick high-level overview of what our Puppet environment looks like, and then we're going to talk about our local workstation setup, tools that we use. Then we're going to talk about how we solve problems, how we approach problems, because for us, how we do things is almost as important as what we're actually doing. So making sure that we're all kind of of the same mindset, and that helps us produce similar looking code. We'll talk about our branching strategy, and then ultimately how we get from commit to automated testing, and then finally published in production. If at any time we have any questions, I got the green light to go a little over, so feel free to stop me at any time during the presentation. If we're using terminology people aren't familiar with, just raise your hand, and we can slow it down. So first we'll talk about our Puppet environment. We use Stash. We don't actually use GitHub. We host Stash internally. And we basically have two primary branches that we work on. We have master and developer. The master branch is tied to our production environment, kind of like what we were talking about just a few minutes ago with Chad, our different environments. So master is tied to our production environment, while develop is tied to our pre-production environment. These environments actually have completely separate Puppet masters. Chad already said that that's a horrible idea. It actually works out for us. The primary reason we do it is, how many people have a pre-production environment in their shop? How many people, boss thinks it's cool if pre-production's down for a day? Oh wow, you guys are lucky, don't leave. We have a very robust pre-production environment. Basically, every development team has their own integration environment that they test with. It's all managed via Puppet. We have a certification environment, which is basically a replica of our infrastructure, also managed by Puppet. But because we make heavy use of things like exported resources and things that are very specific to the Puppet master that we're dealing with, we thought it was best that we separate the two environments so that as we're doing testing in pre-prod, we're not blowing anything up in production. So the pre-production environment has its own CI server, its own set of Puppet agents. The major difference between the two environments is that the pre-production Puppet master has its own remote Git repository on it. And we'll talk about that in detail in a little bit. Yes, sir?
What's the CI server?
We're using Jenkins. Because Jenkins, right? Someone wanted to bring in Team City and they were like, well, why? Like, well, Jenkins sucks. And they were like, no. But you believe it sucks too, right? Yeah, but we're not changing. Okay, roll with it. So we'll talk about our local workstation setup. Not going to get into the editor holy war. I'll just tell you that Vim is the right choice. Don't use anything else. How many are Vim users? How many of you are crazy enough to still be Emacs users? All right, can't wait to tell about it. I love Vim. Vim is my jam, right? Because Vim is so absolutely customizable, it's flexible. It's got all types of syntax highlighting. There's pretty much nothing you can't do in Vim, in my opinion. We use tmux. The combination of Vim and tmux, how many are familiar with tmux? All right, awesome. If you're not familiar with tmux and you guys do a lot of command line stuff, definitely check it out. It's a terminal multiplexer, and it basically allows you to split your screen in multiple ways, kind of similar to what like iTerm will allow you to do, or what's the Linux tool, Mux? Yeah, well, not screen. There was another terminal multiplexer that Linux has, but it's similar to screen as well. But the combination of Vim and tmux really increases our productivity because it allows us to do just about everything from the keyboard, right? We very seldom have to take our hands off the keyboard to the mouse because we can jump between screen sessions. We can have different terminals up showing us various bits of information. And I think in the next slide, we'll show you a snapshot of what our environment looks like when we're developing. Nerd Tree is a very simple plugin for Vim that just gives you some directory browsing hierarchy on the side. You're probably thinking, wow, Vim is so cool that you're excited about a directory tree. But if you use Vim for any amount of time, you're probably like, yeah, that's a little helpful. And then the last tool is Powerline, which basically is just an enhanced status bar that kind of gives you a lot of information about your environment at a glance. What branch you're on, what server you're on, what directories you're in, and any bit of information that you can really jam in there. So, oh God, you can't read that. That looks terrible. But this is a screenshot of what our development workstation would look like. So on the left there, you've got Nerd Tree for browsing the directory structure. The main pane is, our editor window. To the right, on the top and bottom, are different terminal sessions so that we can get all types of feedback as we're actually going through the development process. I think right here we're just running top because it looks cool, but up here we're using a tool called Guard, which we'll talk a little bit about. But it's nice because it's all on one screen. You can get constant feedback throughout your process. You can kind of read our tmux info down at the bottom so that we can kind of hop between different server sessions or even different local configurations. But the nice thing about it too is if you're using something like tmuxinator, anybody familiar with tmuxinator? Tmuxinator is a tool that allows you to predefine your tmux sessions, right? So you can, in a file, say, when I launch tmux and give it the value puppet as a command line, build my windows like this, and then in each of these windows, start these commands, right? So that helps us because when I do mux puppet, the first thing it does is it launches all my windows, and then in a separate pane, it launches several other windows, starts my Vagrant environment, and starts the provisioning process for my Puppet test environment. And it's kind of all automatic. And you'll notice that's kind of a theme. We try to lower the barrier to testing as much as possible. So as much as we can automate, the better. So we'll talk a little bit of our local testing tools. A lot of them are familiar. You guys have kind of heard about them already today. JSON lint, absolutely important for us. In our environment, we use the JSON format for Hira, and Hira is absolutely critical in our environment. And I don't know how many times before we started using JSON lint, we had commit messages like, forgot the brackets, missing comma, God, I suck at JSON. You would have like 7 commits for one small change, and you're like, really? Really? So installing JSON lint locally really helped reduce that quite a bit. Puppet parse and validate. It's a command that a lot of people miss. It's built into Puppet, and guess what it does? Validate your manifest, right? So you can do Puppet parse and validate instead of waiting till you get to commit mode and your auto commit rejects your commit. You can just run it on your command line and validate your manifest and make sure that it's syntactically correct. Because I don't know how many times I've missed a comma, missed a curly bracelet, made up a completely different resource type that doesn't exist anywhere in the world. And then ultimately there's the ERB syntax checker, kind of like Puppet parse and validate, but for your ERB templates. And I must be talented because I find new and unique ways to screw up Ruby templates all the time. So kind of going back to this really quick though, one thing we like to do, again, is reduce the friction between testing and feedback, right? We want that to happen as quickly as possible. So one of the things that we do leveraging Vim is we've created a BIM Linting function, which basically with a keyboard command, I think mine's Control L, It will execute this function, which will determine what file type am I, and then run the appropriate linter for that file type. It saves a lot of time when you're just going around making a couple quick changes. Control L, you'll get feedback in one of those TMUX windows letting you know that, yep, everything looks good, or nope, you forgot a curly brace. Again, reducing the amount of time between testing and feedback and being able to execute that quickly really makes a huge difference. Guard is another tool that we use. Guard is popular in the Ruby ecosystem, and it's basically a file watcher. So in the Ruby ecosystem, you launch Guard with a configuration file, and you tell it, monitor these file types in this directory structure. And Guard just sits there and monitors, and when it detects a change, it will run a series of predetermined scripts, in our case, tests. We do the same thing in Puppet with a tool called Guard Puppet. And it basically sits there and watches a directory structure, and every time something changes, it runs those series of tests and let us know what failed and what passed. It's great feedback. Again, it lowers that barrier, and you're getting that information instantly because you got to save the file eventually. And when you do, your tests are automatically executed. And that's kind of what you see up here. Of course, this is a fail test, but that's Guard running in the background. Save the file, giving me a bunch of info back, letting me know how much I sucked. True story. You can find out more info about Guard, or if you just Google Guard Puppet, you'll see a ton of different types of plugins as well for Guard. So it's not just a Puppet tool, it's really helpful. Our Vagrant environment. We leverage Vagrant heavily, and it's part of our local development process, right? So we have a Vagrant file that we all contribute to, we make changes to, and we store it in our code repository, separately from our Puppet code base. But the Vagrant file basically produces a Puppet master, 2 agents, only one is started by default for resource reasons. And when you provision it, it creates the Puppet master, installs it fresh, wires an agent up to that Puppet master so that when it's done, you have a agent that's already registered with the Puppet master and is ready to receive code. It really, really cuts down on the amount of issues that we run into when we actually get into the pre-prod environment, because you can do a lot of this testing locally. The other big thing is we share our local Puppet repo module with the Puppet master in Vagrant. And what I mean by that is, what a lot of people do is they set up their Puppet master in Vagrant, and then they have to get their Puppet code base into the virtual machine somehow, right? So they do an rsync, or maybe they're pulling down the code repository. Vagrant allows you to share folders across the two. So what we've essentially done is, we've set up the Vagrant Puppet master to get its module path from /manifest. /manifest is a mounted share of our local workstation. So what ends up happening is, the Puppet master is reading what's on the host system. So as I change a file, the Puppet master in my VM environment is automatically updated. I don't have to rsync, I don't have to do another git pull. I can make these changes quickly. The other nice thing is, I don't have to commit anything to test out my changes. I can make the changes locally, test them in the Puppet environment in my VM desktop, and continue on. So this is just like this is actually our entire Vagrant setup. So as you can see, it's not a lot, right? We just specify our environment home so everybody knows where that's at. We set up a private network. We've got an option for a Puppet agent, and then we run some bootstrapping scripts at the end. The bootstrap scripts basically tailor the environment specifically for Grubhub, right? The nice thing about that as well is that tailoring allows us to override particular values that may only exist in a data center, right? So now that we're in our local workstation, we can use custom facts to make our local workstation pretend like it's a node in the data center, or pretend like it's a node in AWS. And that offers us a lot of flexibility in our testing because, like I said, we use Hyra a lot. Like, all of our data comes out of Hyra. So it's easily conceivable that someone could put data in a Hyra file that doesn't have like a default value. So what ends up happening is you run Hyra and it works on your local workstation, but then you run it and the property that would come out of the data center section is empty and your environment blows up. With this, we can override those values and test in just about every configuration that we can think of. And we use that, and we leverage custom facts to do that. Is anyone using custom facts? So we didn't use custom facts originally because we looked at all of the code that we had to write to kind of do that and deal with it. And then somehow we were scrolling down on the page and we were like, oh, wait a second. We can just create a text file with key value pairs? That's it? Those are all the custom facts. Has anyone seen that on the documentations page? Check it out on the Puppet Lab site. You literally can create custom facts just by creating a text file and putting key equals value, and that will show up in Factor. It's amazing. Change your life forever. So how we approach development. These are sort of the guiding principles that we kind of talk about in Grubhub, and we actually use these terms quite a bit. Like as we're discussing a solution, you may hear someone just scream out one of these terms. YAGNI, we'll dig into that. Dry, don't repeat yourself. Make sure that when we're developing modules, we're developing using the modules, profiles, and roles pattern. Anyone using that here? Anyone heard of it here? People heard of it? Okay. We'll dig into modules, profiles, and roles. It's really awesome. The biggest one, have respect for what you're doing. And we're going to talk about that quite a bit. And then write your manifest in public. So we'll talk about that. It'll make sense. YAGNI, you ain't going to need it. So because we're technologists, we try to be perfectionists, right? We try to be completionists, right? So we have people that will write a module and they'll say, all right, well, I've got this hook if we run Ubuntu, but if we're running Solaris, here's this other hook, and it's like, whoa, 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 bro. We run CentOS everywhere. Everywhere. Well, we could run Ubuntu one day. Yeah, we could, right? And we could run Windows, right? But we're not going that route. So YAGNI is the concept of like making sure that you identify what you really need and that you're not making up code to handle these edge cases that are never going to happen. Now, it's okay to think about that in the future in case one day, all right, this might be a possibility, right? But it could be something as simple as, a variable with a default value that once you're ready to make that change, all you have to do is change the default value or something like that. So always make sure that when you're developing a module, you're solving for the problem that you have, not for the problem that you don't. Because the other thing is, by the time you have that problem, the landscape might be completely different anyways. So everything you built may not be valid. The other thing is, if you're not using it, you're not testing it. And if you're not testing it, it sucks. Right? You know what I mean? What ends up happening is a year later, you're like, oh man, we finally got that Ubuntu box. Let's fire it up. Oh, wow, that's a lot of red. It's a lot of red. All right, moving on. So, YAGNI, and you will totally hear someone scream as they're talking about something, and you're like, oh, we can do this, and someone will just walk by and say, YAGNI, and walk away. And they're like, okay, you're right, you got it. Dry, don't repeat yourself. It's very common to kind of get in the habit of just trudging away at something like a repeatable task that you do all the time, right? You have an implementation of some application service, and then another application service comes out, and you basically do copy pasta, right? Who's done copy pasta? Anybody? Yeah, right? Now, suddenly you got a payroll app named something weird that doesn't make any sense because you forgot to do a find replace in a particular section, right? Everybody's done it. The concept of dry is that as you begin to repeat yourself, you should stop and take hold of the situation and say, if I'm repeating myself, there should be a way for me to modularize this, for me to somehow encapsulate this into something separate that I can then call via a function or a parameter or something to that effect, right? But the idea is now that you're localizing these types of changes into one place. So when you need to make that change, you don't have to go to 18 different modules that are all implementing the same logic. You go to one place and you make that change there, and it gets propagated everywhere. And if you structure it correctly, if you only need to do it for one particular app, it's easy to do via parameterization. You look it up in Hira for the specific app that you're dealing with, and you pass that value into your function. It makes your code more readable. It makes your modules cleaner. And really just helps you sleep at night. And hard coding's the devil. And when I say hard coding's the devil, people say, Well, you got to have a hard-coded value somewhere. Yes, there's nothing wrong with having a variable and saying this variable equals path name, and then using that variable everywhere. But if you're typing the same path name in a bunch of different places in the same module, you know you're probably doing something wrong. You should put that string into a variable, use that variable, because inevitably what's going to happen is someone's going to say, you know, I'm just making up stuff for you to do, so can we change the directory path that app gets installed in for absolutely no reason whatsoever? And you say, okay, I'll do it. Now you got to change that directory path in 15 different places. You know you're going to miss that last one. You know it. You've done it 1,000 times. You miss it, your pager goes off, you're not on call probably, so you know the guy after you hates you in the morning. It's just a mess. Don't do it. Put it in a variable. Hard coding's a double. Modules, profiles, and roles. So modules, profiles, and roles is a pattern that was developed by a guy named Gary at Puppet Labs. Gary, does anyone remember his last name? Yes. He's got a great blog that kind of talks about this, so you can get more detail on it. But the idea is that your modules, as you develop your Puppet code, come in 3 flavors, right? You've got modules, and your modules are basically the building blocks of your infrastructure. It's where you define the modules that do the actual generic work without your specific organizational context around it. So, for example, if you were to go to the Forge and get the Apache module, that would be in your modules directory, right? Because it's generic, it's a base implementation that has nothing to do with your organization at all. It just puts in the building blocks of what needs to be done. From there, you go to profiles. And profiles is where you start implementing your organizational specific language, right? So you use your modules to implement your profiles. So now you've got payroll web server. And payroll web server then leverages the Apache module in order to get the configuration that it needs. And then from roles, well, one other important thing with profiles. Profiles should assume that the dependencies it has are going to be solved elsewhere. And what I mean by that is, you may have an Apache web server, right? You may have an application server, right? And that application server may need Java, but it may need a specific version of Java, right? So before long, you've got this include soup of classes that are getting brought in because you're assuming that when this profile gets applied, it's being applied in its entirety and it needs everything in it in order for it to function. But that's difficult to reason about. It's difficult to figure out where the dependencies lie when you want to change something and say, where are all the places that this gets touched? Now you have to go down the rabbit hole to find out where this happens. If you let profiles assume that all of the dependencies are going to be taken care of, it makes that easier to manage because you're going to put those dependencies at the next layer in the roles. And the roles are nothing more than a collection of profiles, right? And that takes your payroll application to the payroll web server, right? So an example of a role would be a class that says like, include payroll web server, include SSH config, include LDAP config. It's a collection of all these things that makes that final server what it is. And an important note about roles is only assign roles to a node. When you're assigning classes to a node, you only assign a role to that node, and each node only gets a single role. Why is that important? How many of you have worked on a node where you've added a class to a completely functioning node, and then suddenly the node blows up after you've added that class? Right? It's because when you're defining these modules, a lot of times you're defining them without the context of what's going to be around them, right? So all it takes is for someone to have the same clever name as you for a resource to blow the world up. If you manage everything in roles and only assign a role to a node, you at the final endpoint know everything that's going to be in that particular node's class. And it also alleviates you from the problem of, oh man, I need to build that payroll web server, but what are all the parts that go to it? Well, let me bring up one of the other nodes and then just copy all of the classes that I see there. If you only have to worry about assigning a role, that makes it very easy because you're saying, oh, payroll web server node, assign, run it, done. If you need to add something to a node that's a payroll web server node, but you're like, but this node needs this PCI class. Got bad news, it's a different role. Because it's a different configuration, right? It still makes it easier. It's more work in the front end, but I guarantee you it will save you time and energy. Does that make sense, roughly?
Yeah.
All right, cool. Have respect for what you're doing. You're programming. For a lot of systems folks, that's a difficult transition and acceptance to make, right? Because we're like, oh, we're not programmers, we're just doing some shell scripting. It's called infrastructure as code. You are programming. And because you're doing that, you have to treat it with the same respect that any other programmer treats his code, right? So you got to be thinking about tests, right? You got to be thinking about complexity. You have to think about comments. You have to think about, is this the best way to do this thing? You have to think about, is the person after me going to understand what I'm doing here? It's code. And you can make it as easy or as complex as you want, but if you're not thinking about it and if you're not treating it with the respect that it commands, it's going to bite you in the butt. Guaranteed. How many times have you said, oh, I'm just going to run in here and make this quick change, and I don't have time to test it, it's just a small change, I'm going to commit it. Holy cow, that version is not the version number I wanted. Oh my God, the world is ending. What's going to happen? I'm just going to pack my stuff up and just go, and if I'm not fired, they can call me and bring me in tomorrow. But for right now, I'm just going to head home. Have respect for what you're doing. Approach it pragmatically. Make sure you have a process, a methodology in place, because it's important. Then ultimately, write your manifest in Puppet. What I mean by that is, Chad kind of hinted to it as well, where he had a bunch of manifests that were just running a bunch of execs, right? That doesn't mean anything to someone that's looking at your Puppet code, though, right? So if you look at the top example, perfectly fine, valid syntactical Puppet, right? We're creating an opt-app config.ini file. Sure. The content. What's in the content? I got no idea. He's looking at this, right? Now I've got to go look at this config.erb, right? Now I'm sure the config.erb is going to have a bunch of unholy madness in it, so I'm going to have to figure that out as well, right? Or, with a little extra effort, you can write a custom defined type where you say, oh, payroll config. I want to set a property of DB server. And I want the value of that to be dbserver.example.com:3306. If you're coming in off the bench cold, dealing with a manifest that you've never worked with, which one would you rather see, right? Like if you're wondering, what's the DB server? What's the connection? This makes sense to you immediately. It is a little bit more effort to write, but remember, code is read way more often than it's written. Think about that. It's read way more often than it's written. So if you can take a little bit of extra work writing it to make it more readable, it's usually worth it. Future you will love you, right? How many of you are like, oh God, future me is just going to be so pissed off. Funny story. We were rewriting a bunch of the Puppet code, and we had to come up with a config.ini file, and there was one particular application that was going to make it difficult for us to use an off-the-shelf module, right? So the module begins with like 2 paragraphs of apology. It's like, dear God, I'm so sorry. Whoever reads this, understand the pressures that I was under. It's like a complete, biography of everything that was going on at that point. And every time someone reads it, they laugh, and then they see the code. And they're like, it's not funny. That doesn't make it okay. Right? I giggled a little bit, and then, dog. Really? So I apologize for that. Someone's probably there reading it now. So write your manifest in Puppet. It's awesome. All right, now it's time to write some code, right? We got our environment set up. We got our principles laid out, right? We got the lights turned low. Everyone likes the code in low light, right? Who's got programming music? Anybody? Programming music? Yeah. Woo! So you got your Daft Punk going, something in the background. Yeah. Fire up your terminal. What's the first thing you do? You open a web browser, and you go to the Puppet Forge. Don't write a single line of code. Go straight to the Puppet Forge, right? I'm clairvoyant, right? Play a game with me. Show of hands. and I don't know any of you, how many of you are running web servers? How many of you are running a web server named IIS, Apache, or Nginx? All right, how many of you are running a database server? How many of you are running a database server named MySQL, Postgres, or a SQL Server? How many of you have logs that must be rotated? Yeah, you're not a snowflake. You're not a snowflake, right? So chances are there's something on the Forge that meets your needs. Check it out. Now, I'm not saying that you have to use something on the Forge. I'm saying at least look, right? Look. You might be completely adverse to it, right? But then as you're kind of shopping around, you're like, oh, ooh, that's nice. I never would have thought to do it that way. Oh, that's pretty. I'm just going to go ahead and download that, right? So check it out, because the Forge is going to have a lot of stuff. Not only that, but it's less work for you, right? Because at the end of the day, there's always more work than we have time, right? Time is the most precious commodity that we have, right? And the more time you spend reinventing the wheel, the less shareholder value you're giving to your organization. That's a term we use all the time at work. Yeah. Are you adding shareholder value, Jeff? Like I am, actually. I'm adding shareholder value right now. So not only that, but there's more eyeballs on the same problem, right? If you write a module in your closet, and then you come out and you bring it to your other 2 guys on the team, guess what? You've got 3 sets of eyeballs on it. Versus some of these modules have 30,000 downloads, right? And they're running in environments that you're not running in. They're running into problems that you are not seeing, but they're catching them for you and submitting patches and fixes for that. So it's of interest to you to be part of that community. Use it, leverage it, it's worth it. Lots of good stuff. And the other thing is a lot of these module writers, they're out on social media, right? Gareth Rushgrove writes a ton of modules. I made a mention that I was going to start checking out the Docker module, and he tweeted me back, was like, hey, let me know if there's anything missing that you need. Let me know if you're running into any problems, and I'll help you with it. Awesome, sweet, thanks, that's free work. Right? I don't even have to pay him consulting though. Branching strategy. Okay, so your branching strategy that you use at your shop is largely going to depend on what your environment looks like, right? So I'm going to walk you through what we have. So there's 3 phases of development that we look at. We have our local environment, then we move it from our local environment to our pre-prod environment. After we destroy the pre-prod environment, we move on to production. Hopefully, by the time we move on to production, everyone feels safe and happy, and it's all just high fives and lemonade. For our local development, we use Vagrant for our test VMs, right? We make all of our changes prior to committing, mainly so that we don't pollute the commit history, right? Because we want to make sure that our commit messages add value, not that we have to sift through a bunch of messages of like, forgot a comma, forgot this, testing. Because what happens is, it doesn't just pollute the commit you're looking for, it pollutes every commit in the system, because you kind of get blind to it, right? You're like, well, there's no point looking at the commit message because it's all garbage, right? It's kind of like alert fatigue in a way, right? You just kind of tune it out after a while. So it's very important that you make sure your commit messages are meaningful, and the best way to do that is to limit the number of commit messages that you actually have to make. We do squash commits in our environment, but we have a major rule punishable by death. You do not squash a commit once it's been pushed to a public repo. And that just wreaks havoc on everyone else's repo once they pull it down. So if you're working on a branch and you push the remote branch, that's fine, but the minute you merge into developer master where people are working off of, you cannot squash your commits anymore. And if you do, we will flog you publicly. It's the thing. So we use linting. We're testing using our local puppet master VM and agent. We're setting facts, variables, and custom facts in order to simulate multiple environments. Once you're done with your local development, you might move on to writing test cases. That sounds a little backwards in our test-driven development era, but largely we're coming from an environment where people were mostly systems admins, so test-driven development isn't something that comes natural to people. Is everyone familiar with test-driven development? The concept is basically you write the test, then you write the code to make sure that the test pass. It feels completely backwards, but when I do it, it's like, oh, okay, this makes sense. It's a learning curve, so we're still writing test cases after the fact. But we want you to be selective about the test cases that you write, okay? So here's an example. We've got some Puppet code, that's laying down a file, right? And then we've got an RSpec puppet test that says, manifest should contain this file. You know what we call that test in our environment? Puppet. That's what Puppet does, right? Why would you write that test? I think Chad or maybe it was Bill said the same thing. We haven't found a ton of value in writing those types of RSpec tests. There are some RSpec tests that work well, but just confirming that Puppet is doing what it says it's doing doesn't really add value to me at the end of the day. Right, and it's very easy to get caught up in the hype, right? Because if you're on the internet, everyone's like, oh God, you're a moron if you're not writing RSpec tests. And you're like, yeah, what moron wouldn't be writing RSpec tests, right? I'm here to tell you it's okay if you're not writing RSpec tests yet. There are some that are worthwhile, but if you're just going to be doing a bunch of, let me verify that Puppet is doing its job, probably not worth it. These guys are pretty smart. They kind of got it figured out. So I don't need to go back and double check their work. Things that we do write tests for them. File syntax. Sometimes there's a file that for whatever reason in Java hell needs to be a particular format, and it's tricky. We may write a quick regex test to make sure that at the end of the catalog compilation, the file looks like it should, right? So we'll write a file syntax check. Conditional branches. Sometimes those can be a little tricky, right? You're testing a variable, you're not really sure where that variable value is going to be coming from. What happens if things are right? You may want to just make sure that the conditional branch produces exactly what you're expecting. So we may run an RSpec test that passes value A, verifies and passes value B, verifies, and then always pass garbage values, right? Because implicitly, you will always miss the tests that you never actually make. So you kind of always want to make sure that the unthinkable is tested too. Like, well, what happens if I pass nothing to it, right? Because how many times have there been a hire lookup that, somebody said, oh, if there's not a hire, it just default to empty. That's valid Puppet, but if your code's not expecting an empty value, world might end. Interpreted values, we're always testing interpreted values, anything like based off of regex or anything. And then every manifest should test catalog compilation. Does the catalog compile? Simple test. And it's nice because with RSpec, you can also override facts. So now you can make sure the catalog compiles for every combination or permutation of environments that you have, right? So does it compile in the Shy2 data center? Yes. Does it compile in the Shy2 data center with the environment name of pre-prod? Yes. Does it compile in AWS? You can run all those tests before you push the code, merge the code, or push it out and deploy it to the Puppet masters. So getting code to the Puppet master. All right, in our environment, we all work off branches. So we branch off master. Your branch name should be named after the ticket that you're working. Everything has to have a ticket. We're at that phase of our growth at Grubhub. Everything needs a ticket. But it's nice because with the ticket ID, it's easy to link that change to an actual work request. If you're part of the Atlassian family and you're using Jira and Stash, it will connect those two. So if I'm ever going back and doing some research, if you've labeled your branch with that ticket number, Jira and Stash will communicate, link the two, and I can follow back to the Jira ticket and see the comments. So it's nice because you can put a high-level message in the commit message, but then the details of all the sloppy work you did to get to that point can be detailed in the Jira ticket. Once you're done doing that, you push your branch to the remote origin server. So that's basically you have your branch in the master repo off of that. So it'll be go whatever your ticket number is. But then optionally, you can push your branch to the pre-prod Puppet master. As I said earlier in the talk, the pre-prod Puppet master has a remote Git repository on it, and its main function is really to give you the exact same thing that R10K is giving you, right? When we push our branch to the remote Puppet Masters repo, it basically has a post-commit hook that takes that data, copies it to a dynamic environment, and then you can test against that dynamic environment before you merge it into develop and then ultimately into master. Some people do it, some people don't. It all depends on the nature of the change. But it's nice because as Chad was kind of showing us how you can go in and modify your Puppet conf to change the environment, the other thing you can do is you can specify the environment on the command line flag of your Puppet command. So you can do dash dash environment, environment name. So what some people will do is they may make a bunch of changes, and then instead of merging it into develop where it's going to affect all of pre-prod, they'll push their branch to the remote Puppet master, go to a specific integration node that they want to test with, and just specify dash dash environment, go 4215. That will run Puppet with the new code that you've just modified on that one environment, and it allows you to test and make sure that everything looks great. Once you're done doing that, everything looks good, you're ready to commit. We don't allow you to commit to master directly. Well, we do allow you to commit to develop, but we don't allow you to commit to master. We create a pull request from your branch into develop. Is everyone familiar with pull request mechanism? No? So, how many of you are coming from a subversion shop? Okay, so in Git, because branching is so cheap, it's prevalent throughout the entire ecosystem. And what you can do is you can basically say, I have this branch that has some changes that are not in this branch typically being master. You can, through a web interface on Stash or on GitHub, say, I would like the change that I have in this branch to be pulled and merged into this other branch. And that act is called a pull request. The nice thing about the pull request mechanism, though, is that it allows for a conversation to take place around those changes online. So when you make the pull request, you can set your target branch to have particular permissions, like only these people can commit to master. So now, anytime someone wants to commit to master, they have to use a pull request, and it gives you a chance to review it and approve it. You can say if someone is going to commit if someone's pull request wants to be merged into master, it needs to be approved by X many approvers. And that allows you to kind of force the conversation around the changes so that we know that other people are involved, they understand, and they approve of the change. I was talking with the gentleman earlier. It's perfect too if you want to open your Puppet environment to other contributors, but don't necessarily want them to have the ability to just go ahead and make a change. I think the example he gave was, a developer wants to make a change, but we want to make sure he's not changing the root password. Well, the developer can't commit directly to master. The developer can push his branch, make a pull request, and then add a series of approvers on the pull request. Then only approved people can merge that into master. So it gives you an opportunity to review it, gives you an opportunity to comment on it, have some back and forth, possibly update the pull request if necessary, and then ultimately merge it. Auditors love this, right? Because it's a documented conversation about a very specific change. And if you're using the JIRA ticket number, you can tie that change in conversation to a ticket number with an actual requester. It's like auditor heaven. They love it. They just, oh my goodness, this is amazing. Then they ask for more information and you cry. So in our environment, you have to have 2 approvers to get merged into master. Only our systems team can actually merge. So we're always ensuring that at least 2 people on the team are aware of a change that's going in. So walk you through real quick. So that's our local branch. The rebase local branch is basically where we would squash our commits in the event that we had a bunch of commits. Push branch to origin, pull request merge to develop, no approval needed there. We perform automated testing. So we have a continuous integration server, Jenkins, and it basically monitors the branch for changes. So in pre-production, it monitors develop. In production, it monitors master. When it detects a change, it checks the branch out. Because, I kind of skipped over this part. So our repository is a single repo. All of our Puppet code is in a single repository. Don't do this. Don't do this. Please, it's not worth it. It adds a lot of complexity, but at the same time, it simplifies things. Where it adds complexity is that now we have this entire repository that's changed, right? So when we pull it down, we have to have a custom script to figure out, well, what changed? And now that we figured out what changed, we have to figure out, okay, now what tests do I need to run to make sure that change doesn't impact everything? If you were running it in a single module, you could just say, oh, run all the tests in the module and be done with it. But because our repository is so large, if you did that, every commit would take 20 minutes to get through the testing. So we have to jump through hoops to kind of, figure out what is it that changed, how do we know what needs to be tested in order to ensure that change. We take a best guess at it and we run those tests specifically. And honestly, it's a trade-off, right? We're saying, well, We might miss something, but it's better than having every commit take 25 minutes. So after the automated testing happens, if the test is successful, it gets pushed to the puppet master. If it's in pre-production, it's the pre-production master. If it's prod, it's the production master. And then in production, our puppet agents are running Puppet every 30 to 45 minutes, I think. We kind of stagger it out. So once it's in master, you just kind of sit and wait, and eventually it'll happen, or you can force the run immediately if you want to, if there's some specific change that you want to make sure got out there quickly. Now, common feedback about the two approvals is, well, what happens if there's an emergency and you need to get something out fast? Is there a way to bypass this? No. And that's good and bad, right? Problem is, in an emergency, it's probably when you need the approvals the most, right? It's 2 a.m., site's down, your boss is down your throat, you're trying to figure this thing out, you think you fixed it, you want to push the change out. That's when you really need someone else looking over your shoulder, right? That's when you want someone else to look and say, yes, this makes sense, let's do it. It does suck because it means you got to wake somebody else up, but ultimately it's worth it. And honestly, the situation doesn't happen that often for us. Another point I should make too. By default, our automated testing for deployment in production stops running after 4 p.m. And the reason that is, at Grubhub, we kind of have this weird inverted schedule, right? Because our busy time is usually off hours for most people. So 5 o'clock to 8 o'clock, that's our prime time, that's dinner time. Everyone's home, ordering food. So those are the periods where we're like hands off. Saturday and Sunday, it's kind of sweet, right? No more weekend maintenance. Hey, I can't do it. Everyone's ordering pizza. You know. How about a Tuesday around 11 a.m.? How's that sound? Good. So works out. So yeah, that's the workflow there. And our deployment process is simple, stupid. It's just a checkout and then an RSync. Nothing pretty, nothing fancy. In fact, the more you talk to people that are doing like this type of continuous integration stuff, the more you quickly realize that like, oh, these guys are implementing really simple solutions. Like, I don't know if you guys follow Etsy's blog at all, but for those who don't know, Etsy is like the engineering goddesses of technology, right? Like they are the epitome of operational excellence. So we had to talk with them, and they're like, yeah, it's a bunch of PHP scripts we are simple. And you're like, oh, but
Yes.
really? PHP? RSync? But it works, right? It's amazing. Why complicate things? So what does our automated testing look like? We kind of talked about it already. It's a script that executes which files have changed, linting is performed, catalog compilation of change manifests, and then the execution of manifest-specific tests. If any of these steps, each of these are separate steps and jobs, and if any of them fails, we stop, let the user know right away. There's some debate on whether it's worthwhile to run all of the tests and then give complete feedback. But at the same time, we say, you know what, run the quickest tests first, and if they fail hard. Because honestly, this is all stuff that could have been tested on your local workstation, right? So if you waited to this point to do your testing, I really don't feel terrible for you if you have to go through like the whole commit testing. Because all of the tests that are being run are things that you can run locally. Execution of manifest-specific tests are just basically tests that are written specifically for a module, and they just have a common entry point of, breaks, Spec, helper, or something like that. That's just kind of a flow chart of the automated deployment process. We're pulling for change the source code repo. Checkout code runs the automated testing. If it's successful, deploy it. If it's not successful, we alert the developer via HipChat. Developer corrects those changes, recommits, and then it goes back to the process. HipChat is kind of vital to our organization. Everyone aware of HipChat? It's like a chat client that Last Team puts out. Tons of integration. Jenkins has a lot of plugins for HipChat or whatever chat application you're using. I wouldn't say that we're a chat ops operation, but we do leverage HipChat heavily. And it's nice because we have a room that's kind of just dedicated to these types of things that go on. So anytime someone commits code, it posts to HipChat and says, hey, someone did this commit. running tests, tests were successful, deploying the prod, deployed the prod successful. Oh, so-and-so changed a feature toggle, that gets published in this chat room. So it's a nice place where you can go and quickly check and say, well, did something happen? Did something change? And it's really useful sometimes in like an emergency scenario where you're like, okay, everything was humming along fine, and then something broke. Oh, look, Bob's at it again. Let's go slap Bob in the hand. So with that, that pretty much wraps up my talk. When we kind of talk about these things, and this is a problem that I struggled with a lot personally, is that, you know, when you come to these conferences or you read these blog posts, you know, you hear about the end state, but you never really hear about the journey, right? And it's small pieces. You know, you may not be here yet. You might have to take a small piece at a time, little wins over and over and over again. But if you keep doing that, if you continue to iterate, you're going to get better and better and better. You're never going to be happy, but you're going to get better along the way, each step of the way. And that's what's important. And as you get better, as you build confidence, it allows you to move faster, it allows you to feel safer and more secure about the changes that you're making. And everyone's got dirty laundry, right? Like Bill was saying, you know, they've got keys in SSH, or they've got, you know, private keys in their GitHub repo. Wasn't that long ago that we had keys in our repo, right? But we said, all right, we got to address this and rip them out. Bill's going to do the same thing. But there's all this dirty laundry that people don't talk about. So as you're going through these things, you know, don't think that you're alone, right? It's like Michael Jackson, you are not alone. I'm with you guys. Everyone's going through the same problem. So with that, that's it. Any questions?
Have you seen Matt in a while?
Have I see what? Oh, yeah, I've walked by him occasionally and he gives me that.
I haven't seen him in a while. He lives next to me. Well, he used to. He still have the same house.
Oh, I was going to say, you look next to you. You're doing pretty good, bro.
We started out in the same.
Back when I was the
place,
CEO.
so- But yeah, he left. And I was like, we used to hang out all the time. And now he's a billionaire. And I'm like, you know,
Yeah.
we don't talk to each other as much as we used to.
Yeah, he's still, yeah, you get the.
But he still has a house next to me though, so I'm like,
Why get rid of it now, right? Like,
probably he like 2 more houses now. He's bought some place in Lincoln Park, and he has a place in he's building out.
yeah, it's a castle with gargoyles.
Oh,
and
it's
whatnot.
sweet.
No questions? I'm sorry, I couldn't hear the question.
What's the mix of people? Are you going to mostly just straight public?
So it's predominantly the systems team that writes all the public code, mainly because we're still in the process of getting all of those dirty secrets in the repo out. So it's difficult to open it entirely to developers. So we're in the process of implementing a tool called HiRA-YAML, which basically allows you to encrypt all of the secrets. And then once we complete that, we will open the code base up to everyone for read purposes, and then they can submit changes via write. But right now, the systems team is nope, I gave notice, 6 engineers, and we're predominantly responsible for it, among other things. So it's not like we're writing Puppet code all day, but because of the way we've implemented Puppet is integral to our like application deployments as well. So typically when there's a change in an application, we probably have some Puppet changes that need to be made as well. So the number of commits that we're doing is pretty high. Yeah, I would recommend, from our experience at least, you know, if you can generalize what your Puppet configuration is trying to manage, it's probably better. So like I talked to some people and they're like, oh, your roles sound very application specific. Our role is Tomcat. Our role is, you know, web server. But we can't do that. Our roles have to be very specific about the application because of all the application events that we're also managing. And a lot of that information should probably be part of the deployment process of the app, right? Like, no one creates directories when they install Apache, right? But in our environment, if we don't lay down the directory structure via Puppet, the app blows up because it's like, oh, I don't know how to write to my directory.
You had something in there about your test automation about only starting the test or you have to stand or have to look against change standards. How are you doing that as opposed to running all of that?
So basically what we're doing is we're using Jenkins environment variable, which basically provides the last commit that was successfully processed. And then we're basically, the script goes through and walks through the commit history up to the current point and says, give me all of the files that have changed. And then from there, it's running a delta against any manifests that have that class included in it. And it adds those to the test and then kicks those off. It's ugly, but it works.
Are you using work systems at all?
Fork repos?
Yeah.
No, just branches. We don't do anything with fork repos at this point.
Thank you so much, Joe.